Okay, this is number 20. In A, we just want to find the point of intersection of these two lines. So let's say these are the two lines here. So 3x minus y minus 7 and x plus 5y plus 3. So we want to find the point of intersection. So it's basically just want to solve these equations simultaneously. In other words, we want to find the point that's on both of these, or the x and y values that satisfy both these equations at the same time. And there's lots of ways to do this. What I did was I just put them in the general form, the ax plus by equals c form. So I just added 7 to both sides, and I subtracted 3. Now I always label my equations. This is equation 1 or line 1 and line 2, or equation 2. I always label my equations so I know what I'm doing. And then what I want to do is I want to try to fix these so one of my variables will cancel out when I add these. These are sometimes called a linear combination method. When I was a boy, we used to call this elimination of the variable by addition. We also had elimination of the variable by substitution. So there's two main ways to do this when you have these linear equations. Well, I notice that this is almost the same as this. I just need a 3 and a negative. So if I will rewrite equation number 1 exactly the same way. And equation number 2, I'm going to multiply by negative 3. And I put this out front so I notate what I'm doing. So I multiply equation number 2 by negative 3, so I get negative 3x, negative 15y, positive 9. Now I'm not really worried about what happens with these two terms. I just want to make sure that these will cancel when I add these. So when I do add equation 1 and 2, the x's cancel. And negative y and negative 15y is negative 16y. When I add 7 to 9, I get 16. If I divide both sides by negative 16, I get y equals negative 1. And then I can substitute that negative 1 into any of these equations and find out what x is. So I just used equation number 1. This form here seemed to be the easiest. And instead of writing y, I put negative 1. So 3 plus 1 equals 7. 3x plus 1 equals 7. 3x equals 6. X equals 2. So there's the value of x. So the point of intersection is 2, negative 1. All right. Okay, and then they want you to shade the region in the xy plane that describes the inequalities. So they're the same equations we had. 3x minus y minus 7 is less than 0, and then x plus 5y plus 3 is greater than or equal to 0. So these are the same equations, so we just want to shade that. So basically, first of all, we would graph the lines, because those would be our boundary points. And then if it's just a less than, it's going to be a dashed line. If it's a less than or equal or greater than or equal, it's going to be a solid line. So I just graph those two lines. And you can see what I did over here. Pretty much matches the answer, but to show you how we got it here. So since these are in this general form, the ax plus by equals c form, it's just easy to try the intercepts. Those are the easiest points. So that's what I did. I drew a scale over here. Hope you can see it. And these are by 2, so this is 2, 4, 6, 2, 4, 6, etc. And negative. And I just tried some zeros. So when x was 0, negative y equals 7, so y equals negative 7. And then when y is 0, I get 7/3 or 2 1/3. So I kind of eye these out a little bit. You could pick some numbers that maybe work a little bit better, but I just used the zeros. So I plotted this point, a couple points here for this line, and now this is going to be the dashed line. So this is my negative 7, so this is my point. Y is 0, x is negative 7. Okay, and then the other point when that's when x is 0. Y is negative 7, and then when y is 0, that means I'm on the axis. X was 7/3, which was 2 1/3. So I just kind of eye this over. This is 2, so that's about 2 1/3. Should be a little bit closer, but so those are my 2 points. So that's 2 1/3, and then this is 7, negative 7, and so I just drew it. And since it was the less than, I used the dashed line. And the same point, this other line, x plus 5y is greater than or equal to negative 3. Then again, I'm just going to use this x plus 5y equals negative 3, and that's going to be a solid line because it's got an equal sign here. And I just did the 0 points here. And when y is 0, x is negative 3. When x is 0, y is negative 3/5. So I plotted these points here. So when y was 0, x was negative 3, so that was about there. Okay, and then when x is 0, y was, or when, sorry, yeah, when x is 0, y is negative 3/5, so I'll put about there. If I use graph paper, I could get a little bit better points here when I'm using these fractions approximated. So that's a solid line. So now when we have these two lines intersect, they divide the plane into 4 regions. So we just had to figure out which region is the region we're going to shade, the region that satisfies both these. So what I did was I just tried some checkpoints, and 0, 0 is always the easiest one if it's available, as long as it's not on the line, and 0, 0 right here is available, so I try 0, 0. And I put 0 in here. Now if it's true, that means it's going to be on that side of the line. In other words, 0, 0 is on the top. I'm sorry, we're going to use the dashed line. So the point 0, 0 is to the left of the dashed line. So if I put 0, 0 in this equation and it makes it true, then that's the side I'm going to shade. So I put 0, 0 in this equation, and 0 minus 0, is that less than 7? Yes. So that means the 0, 0 is on the side of the dashed line, so that's the side I'm going to shade. If it was false, then I would shade the other side. And that gives me 50% that I'm on. Now I try 0, 0, and on this line here, this was the solid line. You can see 0, 0 is definitely on one side of it, so I can use it. And if I put 0, 0 in here, is 0 plus 0, that's 0, is that greater than negative 3? Yes. So that means it's on the above, or on the top part of the solid line. So this gives me the top part of the solid line plane that you divide the plane into 2 parts, and this gives me the left of the dashed line, so this is the area that I shaded. Okay? And again, just some more Algebra 1 topics and a kind of a review of that. Okay, so I hope that makes sense. And that's 20.